Imagine a missile that flies hundreds of kilometers, invisible to radar, strikes with pinpoint accuracy, and leaves no chance for the enemy to respond. That's the SCALP EG stealth cruise missile, a game changer in modern warfare. Today, we're diving deep into how this missile works, why it matters, and what makes it one of the most feared precision weapons in Europe's arsenal. Hello, everyone. Welcome back to the channel. Today, we are going to explore one of the most advanced and powerful cruise missiles in the world, SCALP EG, also known as Storm Shadow in the UK. This missile has become a symbol of modern precision strike capability, designed to hit high-value and heavily protected targets from a safe distance. What makes SCALP EG fascinating is not just its range or explosive power, but its unique combination of stealth, intelligence, and adaptability. Unlike traditional missiles, which often rely on brute force, SCALP EG has been engineered with surgical precision in mind, minimizing collateral damage while ensuring maximum effectiveness. In this video, we'll break down the missile's history, design technology, stealth features, guidance systems, combat effectiveness, operators, battlefield use, and finally, what it means for the future of modern warfare. Whether you are a military enthusiast, a defense analyst, or just someone curious about cutting-edge technology, this breakdown will give you a comprehensive look at why SCALP EG is so highly respected. So let's get started and take a closer look at the origins of this remarkable missile and how it became a cornerstone of European defense strategy. The SCALP EG missile was born out of Europe's need for a long-range precision strike weapon that could operate in high-threat environments. In the late 1980s and early 1990s, the Gulf War demonstrated the importance of precision airstrikes using cruise missiles like the American Tomahawk. France and the United Kingdom realized they needed their own indigenous systems to reduce reliance on U.S. weapons and ensure strategic independence. Development began under the European missile manufacturer Matra Barai Dynamics, which later merged into MBDA, Europe's leading missile consortium. The French version was designated SCALP EG, a Système de Croisière Autonome Long Portée Employé Général, while the British variant became known as Storm Shadow. The program officially kicked off in the 1990s, with the first operational deployment taking place in the early 2000s. Both nations invested heavily in research and development to ensure that this missile could penetrate modern air defense networks and strike hardened bunkers, communication hubs, and strategic command centers. France first integrated SCALP EG with its Dassault Mirage 2000 and later the Rafale fighter jets, while the UK made it a key weapon for the Tornado GR4 and later Typhoon aircraft. The missile's design was heavily influenced by lessons learned from NATO air campaigns in the Balkans and Iraq, where precision strikes proved critical in shaping outcomes. Over time, the SCALP EG evolved into a symbol of European defense cooperation and technological achievement, putting Europe on par with the US. In cruise missile capability, the SCALP EG cruise missile is a masterpiece of aerospace engineering designed to combine range accuracy and stealth in one package, measuring about 5.1 meters in length and weighing roughly 300 kilograms. The missile is large but streamlined for aerodynamic efficiency. Its wings deploy after launch, allowing stable flight at low altitudes where it can evade radar detection. Powering the missile is a turbojet engine that provides subsonic speed, typically around 0.8 Mach, enabling it to travel long distances while remaining fuel efficient. The missile's operational range is estimated to be around 250-560 kilometers, depending on conditions and launch platform. One of its most important features is its BROAH's BOM Royal Ordnance Augmented Charge Warhead System, a two-stage warhead specifically designed to penetrate hardened targets. The first charge punches through concrete or armor, and the second detonates inside, causing catastrophic internal damage. This makes SCALP EG ideal for striking bunkers, underground command posts, and air defense facilities. The missile also includes advanced navigation and targeting systems, which we'll explore in detail later, that allow it to adjust its path mid-flight and accurately hit designated targets. Unlike ballistic missiles, which follow predictable high arc trajectories, SCALP EG flies close to the ground, hugging the terrain to avoid detection. Its design philosophy reflects a blend of survivability, precision, and lethality. Each component, from its composite airframe to its guidance systems, has been carefully crafted to ensure that once launched, the missile will almost certainly reach its intended target, no matter how well defended. One of the defining features of SCALP EG is its ability to remain invisible until it's too late for the enemy to react. This is achieved through a combination of low-altitude flight, radar, absorbing materials, and intelligent roading. The missile is designed with stealth shaping, meaning its structure minimizes radar reflections, much like stealth aircraft. While it is not invisible in the absolute sense, it significantly reduces the detection range of enemy radar systems. SCALP EG also uses terrain following capabilities, allowing it to fly just above the ground or sea surface, effectively hiding within natural radar clutter. By keeping low, it avoids long-range detection and limits the time that surface-to-air defenses have to track and engage it. Furthermore, the missile can be programmed to take indirect routes, weaving around known air defense networks rather than flying in a straight line. This intelligent path planning makes it unpredictable and hard to intercept. Survivability also comes from its relatively small radar and infrared signature, which makes it harder for heat-seeking or radar-guided interceptors to lock onto it. In combat environments where modern air defense systems like Russia's S-400 or China's AQ-9 present major threats, survivability is critical. SCALP EG ensures that attacking forces can strike deep inside enemy territory without sending aircraft directly into heavily defended zones. This capability has made it a favorite for preemptive strikes against anti-air defense installations, command centers, and other targets that would otherwise be too risky for manned aircraft to engage. Precision is what separates the SCALP EG from conventional long-range weapons, and its guidance system is a major reason behind its effectiveness. The missile uses a hybrid navigation approach that combines GPS, inertial navigation (INS), and terrain reference navigation (TRPROM). This ensures the missile can stay on course even if GPS signals are jammed or unavailable. As it approaches the target, the missile activates its terminal guidance system, which uses an infrared seeker combined with a digital scene matching area correlator DSMAC. This means the missile compares the actual landscape below it with pre-loaded images of the target area, correcting its course in real time to ensure precision. The guidance system allows SCALP EG to hit targets with an accuracy of within a few meters, making it one of the most reliable strike options available. This is especially important when attacking hardened or high-value targets where a miss of even a few meters could reduce effectiveness. The missile can also be programmed with specific attack profiles, such as approaching from a certain direction or hitting the target at a specific angle, depending on the type of structure. For example, to destroy a bunker, the missile might approach at a shallow angle to maximize penetration. This level of customization allows military planners to tailor each strike to its strategic objectives. By combining stealth, survivability, and pinpoint accuracy, the guidance system ensures that SCALP EG remains one of the most feared precision strike tools available to European air forces. At the heart of the SCALP EG's destructive capability is its BROAH warhead system, which makes it particularly lethal against hardened targets. BROAH is a two-stage design. The first charge acts as a penetrator, blasting through concrete, steel, or earth to open a path, while the second larger warhead detonates inside the target, creating massive internal destruction. This system is what allows SCALP EG to take out underground bunkers, command centers, aircraft shelters, and fortified facilities that would otherwise be extremely difficult to destroy. The warhead weighs approximately 450 kilograms, with a powerful high explosive filling that maximizes its destructive effect once inside. This combination makes it not only a weapon of precision, but also of strategic impact. It can cripple an enemy's command and control network, disrupt air defense systems, or neutralize stockpiles of weapons with a single strike. Importantly, the missile is designed to minimize collateral damage compared to older generation weapons. Its precision targeting and controlled penetration reduce the risk of harming surrounding civilian infrastructure, making it more politically acceptable in modern conflicts where civilian protection is a major concern. The BROATH system also allows flexibility in targeting. It can be set to delay detonation until the missile has penetrated to a certain depth, giving commanders the ability to tailor the strike for different types of targets. Overall, the warhead is not about creating the largest explosion, but about ensuring the most effective destruction of critical infrastructure with surgical precision. SCALP EG and its British counterpart, Storm Shadow, have been used in multiple real-world combat operations, proving their reliability and effectiveness. The first significant use was during the Iraq War in 2003, where the UK employed Storm Shadow missiles to strike key targets in Iraq's command and control network. Later, both France and the UK used these missiles during NATO's intervention in Libya in 2011. They were instrumental in neutralizing air defense systems, bunkers, and key military installations that allowed NATO aircraft to operate safely. More recently, SCALP EG has been employed by France in operations against ISIS in Syria and Iraq, demonstrating its continued relevance in modern warfare. Each time it has been used, the missile has shown impressive precision, striking exactly where intended and reducing the need for multiple sorties. The missile has also been transferred to allies like Egypt, Greece, Italy, and more recently Ukraine, where it has played a significant role in precision strikes during the ongoing conflict. In Ukraine, the Storm Shadow SCALP EG has been used to target Russian ammunition depots, bridges, and command centers, often deep behind front lines, showcasing its strategic value. This track record highlights not only the missile's effectiveness, but also its political importance, as its deployment signals a high level of commitment and support from the countries providing it. Every use of SCALP EG reinforces its reputation as a weapon that can change the balance on the battlefield. While originally developed for France and the United Kingdom, the SCALP EG has since been exported to several nations, expanding its global footprint. Current operators include France, the UK, Italy, Greece, Egypt, Saudi Arabia, and most recently Ukraine, which received them as part of Western military aid. Each country values the missile for the same reasons. It allows them to strike high-value targets without putting pilots and aircraft at unnecessary risk. For example, Egypt has integrated the missile with its Dassault Rafale fleet, giving Cairo a significant long-range strike capability. Similarly, Greece uses it on its Mirage 2005 aircraft, enhancing its deterrent posture in the eastern Mediterranean. For NATO countries, SCALP EG is a cornerstone of collective defense planning, ensuring that allies have precision strike capabilities comparable to those of the United States. The UK and France in particular see the missile as an important tool for power projection, enabling them to engage in international operations without depending on US cruise missiles. The missile's export success also reflects MBDA's ability to adapt it to different aircraft platforms and operational requirements. Each operator tailors its use of the missile to its specific defense needs, whether it's striking insurgent strongholds, deterring rival states, or reinforcing strategic autonomy. With its proven track record and adaptability, the SCALP EG continues to spread its influence globally, solidifying its position as one of the premier cruise missile systems of the 21st century. In today's world, where air defense systems are becoming increasingly advanced, long-range precision strike weapons like SCALP EG are more important than ever. Traditional bombing runs with aircraft are becoming riskier due to systems like the Russian S-400 or Chinese HQ-9, which can engage aircraft at great distances. SCALP EG solves this problem by allowing air forces to strike from hundreds of kilometers away outside the engagement range of most defenses. This capability gives nations the power to neutralize threats before launching larger air campaigns, effectively opening the door for other operations. It also provides political leaders with a flexible tool for limited strikes, sending strong signals without committing ground forces. The missile embodies the modern doctrine of precision, where the goal is to disable an enemy's critical infrastructure rather than inflict maximum destruction. By targeting command centers, airfields, or ammunition depots, SCALP EG can paralyze an opponent without the need for massive bombing campaigns. Strategically, it enhances deterrence, as adversaries know that their most secure facilities are not beyond reach. It also strengthens alliances, as shared missile technology ensures interoperability among NATO and partner forces. In conflicts like Ukraine, the missile has proven how precision long-range strikes can disrupt logistics and command networks, tilting the balance without large-scale invasions. In short, SCALP EG is more than just a missile. It is a strategic instrument that embodies the future of modern warfare, where precision and survivability outweigh raw firepower. Looking ahead, the SCALP EG is expected to remain a core component of European and allied strike capabilities for many years to come. However, MBDA is already working on upgrades and next-generation replacements to ensure the missile stays relevant in the face of evolving threats. The Franco-British Future Cruise Anti-Ship Weapon FCGASW program is one such project, aimed at developing a successor to SCALP EG and Storm Shadow by the 2030s. This future system is expected to combine hypersonic speed, enhanced stealth, and multi-role functionality, making it even more difficult to defend against. Until then, SCALP EG continues to receive software and hardware updates, ensuring its compatibility with modern aircraft like the Rafale F4 and Eurofighter Typhoon. Its combat performance in recent conflicts demonstrates that it remains one of the most effective and politically valuable weapons in Europe's arsenal. For countries like Ukraine, its availability has been a game changer, showing how precision strike capability can alter the course of a conflict. To conclude, the SCALP EG is not just a missile, it is a symbol of European defense innovation, independence, and power projection. It bridges the gap between conventional air power and strategic deterrence, offering unmatched precision and survivability in contested environments. From its origins in the 1990s to its role in today's conflicts, the SCALP EG has proven its worth time and time again. As warfare continues to evolve, this missile remains a key player in shaping the battlefield of tomorrow. If you enjoyed this deep dive into the SCALP EG stealth cruise missile, don't forget to like the video, subscribe to the channel, and hit the notification bell so you never miss our latest defense and technology breakdowns. And tell us in the comments, which modern missile system should we cover next?